Hello, in this video we're looking at 6 basic derivatives, and this video is for learning intention 9. But before we get started, I want to remind you of all the different notations you can use to write a derivative, because there are quite a few to go over. So the first one, which is probably most familiar, is if we have a function y equals x squared, we can write the derivative function as dy dx. And this is actually said dy dx. If you meet someone who's a bit more old school, they might say dy by dx or something like that. So the derivative's 2x. There's functional notation as well. So we'll stick with the same function x squared. I can write the function as f of x equals x squared, and I might denote the derivative by f dash of x, that's how it's said, equals 2x. So these two mean the exact same thing. They're just due to historical reasons. The last one, which doesn't get used as much but sometimes pops up on the exam, is a kind of operator notation. So an operator does stuff to numbers. So 1 plus 1 is 2. The operator's plus. So this time the operator is the derivative operator, and it's often written with square brackets, and you'll put the function inside the derivative operator. Another way to think about it is that's like subbing y into there. That's another way to think about that, because here y is x squared, so d dx of x squared is going to give you the derivative, and that actually equals 2x. So we say d dx of x squared equals 2x. You have to be very careful, because I see people sometimes writing things like x squared equals 2x, which is just not true. What you mean to say is if y equals x squared, dy dx equals 2x, and that's correct. So now that you've got notation down, we can look at some new derivatives. So I'll start with one we already know. So we'll call this number 1. One we already know is, and I'm going to mix up the notations just to keep you on your toes, is if we have the derivative of x to the power of n, you bring the power down and you subtract 1 from the power. So we bring the power down and we take 1 from the power. I like to remember them by saying the sentence in my head. So while I'm taking a derivative, I literally say in my head, bring the power down, and subtract 1 from the power. I have a bunch of these that I have, so I'll share those with you. Bring the power down, subtract 1 from the power. And you saw an example of that before, and you should be really familiar with that. The next one is the derivative of the natural log function. So if you have the natural log function, the derivative of that, and you do not need to know why. If you want to know why, you can track me down at lunchtime and ask me then, but we don't have time to do it in class. The derivative of that is 1 on x, which isn't obvious at all, so you just need to memorize it. The derivative of the natural log function is 1 on x, more specifically, if you have y equals the natural log of some function, so this could be anything here, the derivative of that equals, I think of it as the diff, that's short for differentiate, I call it the diff over the original. And the way you write that is like this. It's equal to the diff, the derivative, over the original. I'll give you an example of that because that looks a bit abstract there. Let's do an example. Examiners love doing these ones because they trip people up. If I have the natural log of x squared plus x, and that's my function, well, the derivative is the diff of that, so that's 2x plus 1, over the original function, which is x squared plus x. Notice that the natural log completely disappears. Diff over the original. That's how I remember it. Diff over the original. So I'm literally saying that in my head every time I do that derivative. Let's see what's next. So number 3 is probably the best one. Number 3 is a favorite. If you have the function e to the x, the exponential function, the derivative is e to the x. It's its own derivative, which is pretty exciting. If you want to be more fancy, if you have y equals e to the power of some function, the way you can find this derivative is by taking this derivative and putting it out the front. Lots of derivatives here. Let me do an example of that. Once again, this pops up a lot, and it's actually not that tricky. The reason it pops up a lot is because people learn this part and only this part, and there's not as much emphasis placed here. So that's why examiners like to put these ones on. If you have y equals e to the power of, let's say, x cubed, then the derivative is the derivative of that, 3x squared, times all of that. That's your answer there. So you can see that it's the derivative of that top part that sits out the front. Now we're up to our trig functions. And you'll find they follow a similar pattern. The derivative of sine of x is actually equal to cos of x, which is really nice. The others aren't so obvious, but that one's quite nice. It's nice that a trig function gives a trig function as its derivative. And it's the same sort of thing as the exponential function over here. So if I have y equals sine of f of x, well, the derivative equals, you take this derivative and you put it out the front, f dash of x sine f of x. So you take that derivative and put it out the front. And I'll give you an example of that. And I'm going to mix this example with the exponential function. What if I have y equals sine of the exponential function? What would that derivative be? Well, it would be the derivative of that, and that derivative would sit out the front. But the derivative of e to the x is e to the x, so that becomes e to the x sine of e to the x. E to the x, sine of e to the x. So that's number 4. Number 5 is the derivative of the cosine function, which is quite nice as well. If I have the cos function, its derivative is not quite the sine function, it's negative sine of x. And it follows the same rule again. So let's have a look at, if I have y equals cos of some function of x, well, the derivative equals negative f dash of x sine of f of x. And I'll give you an example of that. I don't even know what example number I'm up to. I'm just going to make up a number. You can do your own. So if I have cos of, let's say, the natural log function, cos of the natural log function, well, the derivative of that is going to be the derivative of the natural log function, which is 1 on x. It's going to be negative, so it's going to be negative 1 on x sine of the natural log function. So you can see that we have the original function here, we have the derivative function here, we have the negative sign out the front. And lastly, number 6 is the derivative of the tan function. If you have y equals tan of x, its derivative is, now there are a couple ways to write this. It's 1 on cos squared of x. So what this notation means here is cos of x all squared. That's what cos squared of x means. Another way to write this is sec squared x. Now, if you're doing specialist maths, this might look familiar. This is called the secant function, and the sec function is just another way of writing the cos function. So sec squared of x is actually just the reciprocal of the cos function. Each trigonometric function has a reciprocal, so this is the only one you'll need to know, the sec squared x. And it follows a similar sort of rule. Once again, it follows the same thing. If you have, and it's unfortunate because the textbook doesn't do it like this, it tries to build you up to this part, but if you learn these formulas, it will actually save you a few chapters in the book. I'll do an example. Now I'll do a formal one. So if you have y equals tan of f of x, its derivative equals, let me get this right, its derivative is f dash of x on cos squared f of x, like that. And you can see it's the same sort of rule. The derivative kind of pops out the front. Another way to write that will be f dash of x sec squared f of x. Okay, I don't have room here for an example, so I'll do an example of that. Example 5. Let's see, so if I have y equals tan of 2 minus 3x squared, and I want to find its derivative. Well, I take the derivative of this, which is 1 minus 6x, and I pop it over cos squared of whatever that original stuff is. Alright, that's a lot to take in. If that feels like a lot to take in as well, it is, because those are all the derivatives you'll need to know for this entire course. So I went through 6 derivatives there. After this, you'll just be learning some rules, some tricks to do derivatives. Remember, you don't have to know why these arise. You have to know how to calculate them though. And if you have been, thanks for watching.